Good afternoon, everyone, and welcome to our next project show. Team Focus from Politecnico di Milano will tell you about their vision of the new kitchen tools for the moon base station. Thank you very much for joining us. If you would like to submit some questions, please use our YouTube chat. The students will be happy to address your questions after their presentation. Now, I would like to give the word to the team.
Good afternoon, everyone. I'm Francesco Memo, the team leader of the design group Focus from Politecnico di Milano in Italy. Before going into the detail of our project show, I would really like to quickly present ourselves. We are Francesco, Laura, Joao, and Ricardo, 4 students coming from Italy, Colombia, and Brazil, and supervised by the space experts and PhD design professors Annalisa Dominoni and Benedetto Quacquaro. It's a great pleasure to be part of the IGLUNA 2020 mission, and I would say that we had the opportunity to join the program thanks to the Space for Inspiration course held by our supervisors, which is the first and unique course of space design recognized and supported by the European Space Agency. During our Master of Science in Integrated Product Design, we already had the opportunity to better understand the importance of well-being experiences in space environments. And this was really helpful during the development of the IGLUNA 2020 project. I'll leave now the word to Joao for the project show introduction.
Okay, thank you, Francesco. And first of all, I would like to say that we divided the presentation in three main topics: why, how, and what. And starting with why, we started doing an investigation on the date, a first investigation on how the astronauts, how the daily lives of astronauts were organized. And one thing that really interested us was this case about the partnership between DoubleTree and NASA, where they, in January of this year, they baked the first cookie in space. So even in an extreme environment such as the ISS, where all of their needs are very closely monitored and attended to, they still look forward to the familiarity of meals and the emotional aspect of food. In a more serious tone, another case that popped up during this first investigation was the care with microscopic organisms that inevitably live inside the ISS together with the astronauts. At least once a week, they are required to have a deep cleaning session of all exposed surfaces in the station to keep all the life support and electronic systems up and running. As mentioned before, the emotional aspect of the meals was something that caught our attention from the beginning. And to restrict the focus of our project, we decided to limit the scope into the kitchen environment. For that, we used this routine mapping tool where we compiled all the tasks and separated in 4 main categories: the preparation, cooking, eating, and cleaning. And then we highlighted the main opportunities into each of these categories. After all of this research, we extracted 4 main challenges to work with. First, we have volume and flight space. Since one of the most valuable resources in space missions is the flight volume, we need to, all the objects need to be very small and very packable. Second, we have step-by-step usage. These astronauts are always in a constant state of stress, and considering this, all non-essential equipment should not need a specific instruction manual to be used. Third, we have a backup deployment aspect. So because of time constraints and mission planning, deployment of any backup system is very restricted. And finally, we have functionality first. In extreme situations, objects need to be accounted for the most possibilities they are used into. From these main challenges, we extracted the main opportunities combined with what we researched before. So first of all, we need to have a compact object. Second, it needs to be intuitive. The solution needs to teach itself how to be used. Third, it has to be easily repairable, so backup parts that can be transported together and easily changed inside the subsystem And finally, it needs to be efficient and effective, meaning that every decision inside the solution has a specific purpose. Another insight that was brought up during our research was that for the past years, we have seen a boom of space-related projects and values. Two cases of that can be seen on the SpaceX Dragon Crew module, which was docked recently into the ISS and led to the private partnership with NASA and how it was advertised and watched all over the place. Second, we have the partnership between Heron Preston, which is a high luxury fashion brand, and NASA, leveraging the values and the space excitement for their line of clothes. All of this brings hope to us that spacefaring and space exploration goals today are already widespread, and we will soon live a space renaissance similar to the space race. But for us, the most important aspect that we could bring to the project as designers was the materialization of new visions. The way we see to have agency and guide our future towards what we want to, we first need to know what we want and relate the technological and aesthetics implications of that. Two very good examples can be found in the Star Trek series, where in 1968, there was already the concept of the mobile flip phone, which we can see in the image of Captain Kirk with the communicator, even though it would only be technologically viable more than 25 years later, at 1995. The same happens with the pad concept, where characters of the series would sign documents, search databases, and other tasks that for today are trivial. This concept already existed in 1987, whereas the iPad, which revolutionized the tablet market, was launched less than a decade ago, 2012. This is the second important consequence of materializing futures. Once we know where we want to go, we can look forward to technology that already exists or that will exist in the near future and apply it into the vision we want to realize. Now I leave the word back to Francesco, which will talk a little bit about our comparison with IGLUNA and our past projects.
The key point of our project is the cooperation. Even if we are an international team, we have a monodisciplinary background that pushes us to collaborate and cooperate with multidisciplinary teams. Me and Laura, for instance, had the opportunity to physically join the kickoff event in September 2019 in Lausanne, where we directly could discuss with people who approach themes and problems from different perspectives that enabled us to make our project closer to the reality. The Focus project is based on Moon, the new modular lunar base designed by the Politecnico's team during the previous IGLUNA edition. It's a new moon station developed inside a lunar lava tube and mostly 3D printed in Revit, in order to protect the entire structure and to minimize the materials that should be brought from Earth. To create a connection between the two IGLUNA editions, we decided to pay attention on astronauts' daily lives inside Moon, focusing on their physical and psychological well-being.
Hello, everyone. As the final goal of our project, we wanted mainly to consider 5 aspects that we want to achieve. The first one, it was the well-being of astronauts, allowing them not only to survive, but also to live. Then we create objects that have a circular economy. And finally, we use technologies in new contexts, being able to connect individuals and create new perspectives. So for that reason, we would like to show you the following video, which will explain a bit more about the work that we did with Focus Project. So enjoy the video.
The moon. Half a century ago, for the first time in history, we were there. Today, people from all around the world are working together towards one common goal, to go back to the moon. But this time, to stay. Our team is designing for IGLUNA 2020 new ways to help explorers live and feel at home in this new environment. The focus is on a fundamental need, nutrition. Our multi-continental team designed new tools by investigating both the roots of our cultures and new cutting-edge technologies. creating tools for sterilization, preparation, and consumption of food. Through additive manufacturing technology and a remarkable use of material properties, our guests will be able to not just eat for survival, but to experience a well-being moment. The project, in its most immediate output, is a set of tools for human nutrition, but it's also a reflection on how our heritage from Earth can be precious and inspirational for a multi-planetary future.
So, which is the focus of our action plan? Was based on a process of observation of priorities, thus emphasizing in the production of food mainly treated by the other groups that are part of IGLUNA 2020. Despite this, we leave a gap between food production and consumption of food change. For that reason, we would like to create a bridge between these two concepts. In this way, we want to cover this gap, creating a set of intuitive and functional objects that can have a positive impact in the astronaut's daily life by studying each step necessary to achieve this goal. The experience of food is considered 360 degrees, the elements that can be part of the process of innovation which have been developed. At the same time, we have tried to understand how food can continue to link with our origins and be integrated into the emotional part of astronauts' daily life. And for that reason, we have UV disinfection, Sugamusi, Mako, and Arcade. Like this, they were born. And here you can see the overview of our projects. So our first approach was regarding cleaning by avoiding harmful organisms, which could be dangerous for human health. And from the other hand, taking care also about primary sources that are fundamental for the integrity of the missions. So this is our key points of these steps. And in this, UV disinfection has a low consumption of energy, and we consider all the principles described before. About transformation of food, Sugamusi and Mako provide an alternative cooking with not electricity through completely analog principles and natural composed materials. And about consumption of food, Mako and Arcade cover the last process of the food chain. Both subsystems provide an Earth-like alternative to astronauts, improving their mental well-being and through familiarity and comfort. So what about a manufacturing process? We try to compare the most suitable options and following the ISRU paradigm, it means in situ resource utilization, to reduce the material and components to be transported. Trying otherwise to be focused on technologies and take care about how astronauts can be able to print them and after assemble them to obtain final objects. Indeed, the main alternatives are sulfur-based and concrete, powder-based fusion through high output laser device, and self-preparing high-temperature synthesis. So in order to be able to understand all requirements related to geometry and technologies, we select for focus subsystems. Together, we had a collaboration with Superforma Lab, which is a marker place located in Milan, and where we print with clay was 3D machines to evaluate, avoid, and correct possible failures, which maybe have been not seen before. If you want to know more about this, Wednesday we will have a meeting with our sponsors, and if you are not able to follow us, you can see after in our Instagram live. Thank you.
Yeah, so now let's have a look at the concept we developed. The subsystem are an example on how those tools could look like. For each of them, we based our research on how to get the most out of 3D printing space and combine it with an Earth-like food experience. So let's start with Archaic. Archaic is a tool for the production of ice cream on a lunar soil. The idea is to use the external temperature of the moon inside the lava tube to freeze the mixture and deliver a plant-based food without the need of electricity. With this tool, explorers could experience a taste of home and a joyful moment. This is done through freezing liquid, which maintains the low temperature needed. By adding a fluid mixture into the subsystem and mixing it for a few minutes, the host will get a tasteful ice cream. This concept is already proven to be working also on Earth, but with the need of electricity to freeze the cooling block. Instead, on the moon, we could use the same principle by using the average temperature inside the lava tube. The project was born looking at whole ice cream machinery tools and adapted them with new materials and new technologies. Multiple tests has been made to define the final shape. The final product is made by two blue hollow containers where the freezing liquid is stored. And at the center, we have the aluminum goblet for the ice cream mixture. And while the external shell is made out of regolith. So just as Focus was born with the aim of helping astronauts to feel like at home, Mako wants to recreate and revolutionize the whole experience in coffee making. It's a new coffee maker specifically designed to be used without any external heat source, both on Moon and on Earth. The heat needed to warm up the coffee pot water is given by the zeolite, which is a natural mineral currently used, mainly used in professional boilers and in the cooking world. In the market, also in this case, we are already application of this principle. So we look also in this case at the high feasibility in the near future. As we saw yesterday in the SWOC team project show, we will be able to cultivate coffee on the moon thanks to their greenhouse, and then delivering a moment of relax for the astronauts. Also, in this case, most of the components will be 3D printed on the moon. Another example is Sugamuxi, which is a tool for the transformation of food. It's an oven with passive heating and is designed to cook food by conduction and convection. The principle is the same as Mako, as the previous concept. Again, we have a cavity where to store the zeolite, and by adding water, we can raise the temperature in the oven and prepare the food. It's inspired by the pre-Columbian history, and its system of channels between internal and external walls allows to fit the zeolite inside. Its temperature and shape could transmit a sense of hospitality, creating new rituals and gestures for astronauts living on the moon. Also, in this case, again, we focus on imagining 3D printing the most of the parts. Last but not least, we imagine a UV sterilization system, which is an exercise of literally changing context of an already existing and well-developed technology to another context. It's a food sterilizer, and most of the large components could be printed on the moon. Considering that every resource matters in an extreme environment such as the moon, we propose to save water and space through the use of UVC lights to disinfect food, surface, tools used during the food transformation process. The UV light technology is already used and proven on Earth, and it's available with small investments. Because of the size of the concept, the structure can be folded, and inspiration for this were found in the well-known origami. The project itself is comprised of an electronic model with an UVC LED, on and off interface and batteries, and this is all that is packed to the habitat. The other part of the project is the design of a 3D printed regolith enchasing to be produced also in this case through 3D printing regolith system.
Just to sum up, we stressed from the very beginning the importance of the well-being experiences in space environments. And we repeated that our project's main aim was to help astronauts to feel like home. In order to achieve these goals, the role of design and designers in the space industry is extremely important. Our ability to face challenges as opportunities to be seized and not as obstacles to be avoided help us to approach problems from different perspectives and points of view. The space branch represents a great challenge that provides designers a completely new planning area in which to operate. giving them the possibility to show how lateral technological innovations can support human well-being in extreme conditions. By thinking outside the box, designers can really help astronauts to live in space rather than simply survive. All the objects we developed and we explained to you could be useful also on Earth. Sugamusi and Meiko enabled to cook food and to prepare coffee in all those situations in which no energy or heat sources are available, like during trips, camper tours, or inside holiday homes. The UV disinfection tool represents a low energy alternative for cleaning food, while Archaic can be really useful to prepare ice creams, rediscovering ancient gestures and avoiding the electricity use. This was our presentation. Thank you so much for joining us. We wish you found it interesting, and we will be available for any doubts. Thank you again.
Thank you very much for your very beautiful and very inspiring presentation. I see that the audience enjoyed your show as well. We have a lot of very nice comments and interesting questions in our YouTube chat. So I'd like to start with our Q&A session. Somebody is writing in our YouTube chat that the food transformation is sometimes less emphasized, and it's great to see your approach. Do you know what is the current state of art at ESA, NASA? Did you do some research on that topic?
Yeah, actually, this was one of the starting points before our trajectory inside IGLUNA. And during the research for another project, we realized that most of the food that they consume into the ISS, which is our parallel today, it's very similar to what we consume on Earth. The most different aspect of it is that they don't have fresh produce. So, for example, have fruits or vegetables that are packed inside the ISS. Well, to go to the ISS, they last at most 2 weeks. And with this, we are trying to make this connection, since a lot of other groups inside IGLUNA are already working on this production part. We realized that maybe we could transform it into, give a platform to transformation of this produce. But today, relating to the food consumption in the ISS, it's basically the same, except for the fresh produce aspect of it.
Thank you very much for the answer. And indeed, it was really great to see during this year your interaction with other teams and implementing your concept together with them. A little bit more about your vision for the future. So when do you think we will actually be focused on the benefits and wellness of the astronauts rather than on the critical elements of the space mission? So I guess at the moment it's not yet the time, but what do you feel when the time will come?
We are very hopeful that with the upcoming private companies and the less resources spent to go to space, even more so now that SpaceX proved that they can make crew flights, we start to see another boom in space tourism. And if we put these two aspects together, we will start seeing the space as something, as an experience, and not something to be scientifically approached. So instead of making a change from mission critical elements, because honestly, we don't think it's ever going to be different, since it's such a harsh context. We think that pleasure, not pleasure in the vulgar sense, but a pleasure as a nice experience will start to be another focus of space missions.
Thank you very much for your answer. And on the technological side, when do you think this kind of technology will be available, will be used?
One of the main aspects of the Focus project was finding technologies that, as we said, are either already existing or would be very marketable very soon. And when we comprise the UVC radiation, the LED, the zeolite, and also the gelato making process, we already have the technology to make this transition. Now we need to test in a space environment because due to COVID reasons and other various reasons, we couldn't make lab tests or control tests of the technology, but the proof of concept is already done. So the transition is mainly a question of validation.
Thank you very much. Well, congratulations on your project and looking forward to actually see the technology implemented soon. I have a follow-up question. I think you mentioned it into your presentation, but someone from the audience is asking, was the vision to use the lunar regolith as a material for your products?
I think Laura can answer this question, since she was responsible for the material part of the project.
Yes, conceptually, we would like to use regolith, but in this case, it's not really possible for us to taste it. So we tried to find the closer material that we were able to print it, and for the reason we did it with clay, that we saw that being mineral, they have a lot of aspects that can be super similar. So in this way, we were able, thanks to our sponsors, to print them and see which are the constraints and which are really the main points that we can consider in a future concept, we hope, that with printing regolith.
Great, thank you very much. And I have another question. Do you think it would make sense to produce these tools now to be used on Earth? If yes, do you plan it, and do you plan to put them on the market?
That's a great question. Since we already said that the technology is available, the main concern right now is regarding the UVC tool. Since the UVC radiation is so dangerous in the form that it was applied in this project, we very carefully put lots of safety nets inside the project. And if we replicate into homesteads, maybe we don't have the same care or using that technology. Regarding zeolite, and we already have some applications. For example, in the past 3 years, if I'm not mistaken, there was already a chef that were cooked in Venice using zeolite, and he was serving only dishes cooked through the zeolite method, which is very simple. You have the zeolite and you add water, and then you have a thermal reaction that generates heat. So we see it a very we see a very possible way to put them on the market. However, the main focus, we wanted to seize the opportunity in this project to realize futures. So this is why we decided to go in this movement. We have a technology that we have on Earth, and maybe we can apply on space, and we think we can. And this movement, we wanted to inspire other people to do the same, to start looking for opportunities of technological innovation here on Earth.
Thank you very much. It's great to see your motivation and inspiration. And in fact, I noticed there was even another question from the audience asking again, do you have your products for sale? So somebody is also asking in our YouTube chat, will you bring your system to IGLUNA 2021 and will be able to try your gelato?
Oh, I think Francesco can answer this one a little bit better, because he was the team leader in contact with IGLUNA.
Well, we were thinking about it, but we have several constraints from now to the IGLUNA 2021 mission. First of all, we are going to finish our studies in integrated product design at the Politecnico di Milano. So probably we can organize with our supervisors the next generation of designers and space experts for the IGLUNA 2021, as we continued And we used Mooney, what the Politecnicos did last year during the IGLUNA 2019 edition, as the starting point of our project. Probably our idea and our mission can be the starting point for the IGLUNA 2021 mission from other students from the Politecnico di Milano.
Thank you. Looking forward to the next year edition. Now I have some more technical questions about the current projects. Somebody is asking, how do you prevent water absorption into the material?
That's a very good question. Laura and Francesco, I think if you jump in on it.
Yes, of course. Actually, with the material that we are using, zeolite, it absorbs directly the water, so we don't have this type of problems. Because as Joa explained before, there is this kind of chemical physical reactions that permits that zeolite absorb the water that we will introduce, and after that, it will be evaporated and produce heat. So yes, actually, we don't have these kind of problems, even though, yes, it's a super good question.
Thank you very much for your answer. I have another question about the UVC. Could you remind us, is the UVC safe? What safety measures you applied for the project?
Okay. First, I need to explain a little bit how UV rays work. So we have three main categories of ultraviolet rays. We have UVA, which is completely safe to humans, and it works as it's the type of light we use in parties where we want to have that dark light and this type of stuff. It's also responsible for the tanning procedure. So we get tan because we get exposed to UVA. UVB, on the other hand, which has a shorter wavelength, instead of tanning, it starts to burn the skin. It has more energy and it starts to penetrate the skin, and the UVB is what causes sunburns. UVC, on the other hand, we don't have on Earth. It's completely absorbed by the ozone layer, so every UVC ray you see is produced either outside of Earth or by artificial means. Because it has such a short length and it doesn't even penetrate the ozone layer, anything can stop it from spreading. So we used a polymer origami shape to encapsulate the UVC inside the system, and we put two infrared sensors inside of it. So anytime you turn it on, it calibrates the infrared, and if it detects any different spectrum from what it calibrated, which it would happen if you would open the casing of it, it shuts down the system completely. Because as you said, UVC is not safe for humans. That said, there is some research on a new type of UV rays called far UVC, which theoretically it's safe. It's harmful enough to disinfect surfaces, but it's not. Its wavelength is short enough that it doesn't penetrate skin. So it should be safe for humans, but there are tons of research on it, and we decided, since it's so recent, we decided to not use it.
Thank you very much for this very detailed answer. It's really great to see how much research you have done and how well you thought through every detail of this project. It's a pity that we didn't have the chance to try and see all of your project this year. So now that we were talking about the UVC, and I remember you plan it as an origami shape, kind of, I have a question from the chat. Somebody is asking, have you thought about making origami shapes, since saving volume in space is critical? So I guess it's regarding the other objects. Have you thought about origami shapes for them as well?
If anyone else wants to answer this one too, or complement my answer, the attractive the attractive part of origami in the UVC aspect mainly was that if you take a look at the 4 projects, we have 3 completely analogic projects and 1 that is heavily electronic. Because this single one is electronic, we decided to save space as much as possible on this one. And because of that, we applied the origami shape. So because of, since we are saving as much volume as possible, the only thing to be shipped inside the UV system is the electronics and the folding, because we needed something that would be expandable and also and at the same time it would be movable, let's say. The other projects don't need that, and because of that we decided to mainly use the 3D printed parts that we thought on using the regolith, as we explained before. We could probably transfer the origami shape to the other ones, but we didn't see the need of it.
Thank you very much. Somebody is asking also, how did the idea come from? I remember you were talking a little bit about this at the beginning of your presentation, but in case you would like to add something, how did it start and why did you choose exactly these 4 objects?
This was mainly personal. We decided from the beginning to have each person responsible for a single subsystem, and have something that tied them all together. Then we took a look at all the environments we could work inside the space station, because since the beginning we thought about using the Mooney project as a basis for it. And if you take a look at the Mooney thesis or at the Mooney results, they have a very large common room, which they use for most of their activities. So they use for cooking, they use for leisure, and since it was one of the biggest rooms inside the concept of Mooney, we decided to approach it and involve all of the other projects inside. So instead of using the living quarters, the bathrooms, or these other facilities, we decided to use the common room just to emphasize the emotional aspect of it. And among all of possible tasks, food was one that was very attractive for us, because we are immersed in an Italian culture, and meals are bonding for us. It's a very emotional thing.
Thank you very much for this very nice answer. I do not see any further questions from our chat, but we still have a little bit of time. This is your chance in case there is something you would like to add to your presentation. If not, then I would like to conclude this session. Thank you very much for your very nice presentation. It was very inspiring project show. Thank you very much, everyone, for submitting your questions. That was also a very nice discussion afterwards. Thank you for watching us. Please stay tuned. We have a guest from Astrocast giving a talk soon. Thank you, the team, and thank you, everyone, for watching us. Have a nice day and goodbye.
Hi everyone, welcome back to the IGLUNA virtual field campaign, and I'm happy to have you today with me for this space experts talk. Today we have Fabien Jordan from Astrocast. Fabien is the founder and the CEO of Astrocast, and I think he has a really interesting story to tell us, because Astrocast started as a student project at EPFL. So EPFL is the technical school University of Switzerland in Lausanne, and they started as a student project called SwissCube. They launched the first Swiss CubeSat, and I think the CubeSat is still operational today, but they had a long journey until now, and today they are a startup, and Fabien is going to tell us about their journey from this student project towards successful startup. So Fabien, please tell us more about this project.
Hi everyone, thank you Gaëtan. Nice to be here. Thank you for having me here on this IGLUNA program. It's a pleasure to be part of that. I'm just trying to. I have to tell you, I have a little issue with my file here. I was just trying to start my PowerPoint presentation, and I might have to do something here. Let me try that.
I will give Fabien a bit of time just to put his file together.
It's the demo effect. I might have to just quit and come back. I'm really sorry for that.
It's no problem. I can talk a bit in the meantime.
Yeah,
so I'm not an expert of what you guys are doing, but I mean, running a student project as a CubeSat is quite amazing, especially 10 years ago. So right now we have more CubeSat projects. There is another one running now in Switzerland called Chess, with other instruments inside of the mission. But SwissCube was quite an experience, and I think there is a lot of people that continued working in the field afterward in Switzerland. So the student project really went further than what we were expecting, or Switzerland was expecting for it. So I think it's a great project, or a great history for this type of projects, because when we look at IGLUNA's projects today, we can expect some of these projects also to fly further and become a successful startup as Astrocast. So I'm really happy to have you today with us, explain a bit more what you guys are doing. So I think I see your screen now, and I will let you go back to the presentation. Yeah, thank you.
Okay. Sorry for that. Thank you for the introduction. Well, thanks for having me again on this program. It's great to be involved. I've been watching some of the student presentations about the moon habitats, the hydroponic systems, and many other things. It's quite exciting. It's fascinating. I have to admit that personally, I don't know much about the moon. I've learned a few things when I was working at the Space Exploration Institute in Neuchâtel with Dr. Jean-Luc Josset, who was part of the very successful SMART 1 mission. This is when I learned a bit about the moon, the ice in the craters, etc. I know a bit more about Mars, as I was involved in the ExoMars rover mission for a couple of years. This was very exciting as well. I was technical manager for one of the scientific instruments on board the rover. But as you probably understood, the theme of my presentation is going to be not about space exploration. It's not going to be about Moon or Mars. The focus will be on our planet Earth. And my presentation will be about how we came up with the idea of building a global IoT network, how the system works basically, and why it is important to have such a network in place. I just want to make sure you still hear me correctly and everything is displaying fine, because I had this little issue. Okay, great, thanks a lot. So what is Astrocast? First of all, Astrocast is an amazing team. It's an amazing team of about 50 members now. This is a picture that is already quite old, because I don't have recent pictures of the team because of COVID, as you can imagine. But this is a picture of the R&D team mostly. We have an amazing team of agile engineers, space enthusiasts, IoT experts, and many other talents. We did put together this group of people because they have the right mindset. They are people who understand what new space is, they understand what it means. There are people who are always ready to challenge things, to challenge the status quo. And I have to say, I'm very proud of this team and very honored to work with them every day. It's been a beautiful experience so far. Astrocast, it's not only a team, it's also a vision. We believe that not only there are fantastic business opportunities in providing connectivity solutions globally, but we are convinced that we can support a lot of important sustainable projects globally by providing low cost and very practical solutions that can provide significant benefits in many sectors. We're going to talk a little bit about the sectors, but it touch very different verticals. And this is also a very fascinating part of this business, is that we are actually using space to serve multiple industries on the ground. With Astrocast, our customers will be able to manage their assets much more efficiently. They will save costs. They will be able to control and reduce their emissions output. They will be able to raise productivity in some cases. In other cases, they will be able to provide a more safety at sea when people are in remote areas on the oceans or working in very remote part of the land, and many other benefits. Astrocast is also a building. This is our new facilities in Chavannes, not very far from EPFL in Switzerland. Astrocast was created in 2014, and we are what we call the fully vertically integrated nano-satellite IoT company. What does that mean exactly? Well, we are basically a telecom operator, which is only focused on the Internet of Things. So we are not a broadband operator. We focus on short messages, sensor data, and this kind of IoT messages. And our system, our infrastructure is based on a network of nanosatellites. These nanosatellites, they are designed and produced by our team from scratch. And not only we produce them, but we also operate them in orbit. So we have an operation center. I'll show you a picture of that. And we also develop the product. So we have product that allows our customers to exchange data with their assets anywhere in the world. And we were actually the first startup to start thinking about targeting the IoT market in remote areas using nanosatellites. Today, there are many other startups trying to do something similar, probably between 15 and 20. But given our advance and our technological developments, we are in a very sweet, very strong position to lead this race. So let me show you a few pictures of our new facilities in Chavannes. This is our CTO's office. This is where we have different incredible brains colliding together to create pure technical innovation. So we have a couple of geniuses in our team who are really impressive in their ability to develop new innovative technical solutions. This is our new lounge where we can not only drink coffees, but where I'm convinced many more creative ideas will emerge in the coming years. Some pictures of our labs. We have 4 labs on the ground floor of our building. We have a machine-to-machine lab, or we can call it also the IoT lab, where we do a lot of telecommunication testing. We have a prototyping lab. We have a flat sat lab and a clean lab. So this is part of the clean room. You can see here the flow boxes where we integrate the satellites. And the satellites you can see here is a 3-neat CubeSat. This is one of the 5 flight models that we are preparing for launch later this year. And here you can see one of our key engineers doing some testing on the ADCS, the attitude control of the satellite. This is our thermal vacuum chamber, where we do a lot of testings. This was one of our first investment, and a very important one, because we can be very agile in our development process. We can shorten the development and the testing cycles by testing every single subsystem and satellites as soon as they're ready. And here you can see one of the flight models being installed inside this vacuum chamber. Here's a picture of our mission operations center. So this is where we operate all the satellites that we have currently in orbit. We have 2 precursor satellites in orbit, and we will launch about 80 of them. So we are now prepared to monitor and control all of these satellites from here, from our same facility. This is also where we not only monitor the satellites, but the entire network and the security aspect of the network. The many other teams in this company required to operate the business. I will spare you the details, as most of you are interested in the space side of things. But really, if it is your intention to grow a business based on your new developments, on your new innovations, keep in mind that all these other departments and all these other things are extremely important when we talk about finance, regulatory, infrastructure, HR, business development. All these elements are as important, if not more important in some cases, for the business viability and for the growth. And this is something we have, as engineers, we always have a tendency to forget, or to maybe not take into consideration at the beginning. So that was just a small parenthesis. So now let's go back to the first question. How did we come up with this idea of building a global IoT network? Well, we came to the realization that only a fraction of the globe is covered by cellular networks. It is estimated that it's roughly 10% of the surface of the planet that is covered by terrestrial cellular network. So it basically means that there is only 10% of the planet where you can connect an asset and relay data or messages using the ground infrastructure. Everywhere else, you need to rely on satellite connectivity, and satellite connectivity does exist, but it is very expensive, and it's not at all affordable for all the applications that we are targeting with Astrocast. Really the question was, how could we extend this coverage of the IoT, or this ability to relay messages everywhere on the planet? So really that was the first realization that we had, and we started working on these questions. We were convinced actually that knowing what a nanosatellite can do, knowing the potential of the technology, we're convinced that we could potentially solve this problem using a constellation of small satellites. But it was very complex, which is the reason why we did it, and we liked it. Complexity is actually very appealing, not only from the technical side, but from a lot of perspective. Some of these difficulties are we're still trying to grasp and understand them as of today, after 5 years, because it's such a complex environment. But that's the beauty of the project. So from the technical point of view, the question was basically, how do you design a complete system that can offer a connection to any IoT device on Earth in a few minutes? And how do you make that system two-way, so bidirectional, so that you can not only receive messages from your asset, but you can also send commands or software updates or any type of data? And how do you make that system secure enough to not be blocked by security issues that we all hear about, especially in the IoT? And most importantly, how do you make it cost effective? Because the price point of your solution will define the size of your market and your ability to penetrate these markets. So I'm not going to tell you exactly how we did achieve this, because it would take several hours, but we did find a very elegant way to make the system work. Together with Airbus, one of our strategic partners, and other very important partners, we have co-developed the most efficient data protocol to manage the traffic generated by all these devices on the ground from the satellite perspective. We have secured access to the best frequencies, the best spectrum that you need to efficiently, at low power and using miniaturized antenna, efficiently transmit your data. And basically, we put together a whole portfolio of technologies that allow us to relay short messages from anywhere on the planet in a secure way. And then we can securely store and manage this data on our database system for our customers. So we really designed a system that we control completely. We control the entire chain from the device to the database system, and using optimized technology, not reusing technology that were designed for the ground that are not very efficient for configuration with satellites in low Earth orbit. So here is a sample of some of the applications that we are going to serve. There are thousands of verticals we can address with this kind of technologies, but to give you some of the project that we also really like and where we can have a strong impact. Weather stations, we can connect weather stations in remote places. We can connect drifting buoys to measure different parameters of the water quality, the climate. Many applications in the maritime industry where we can provide an elegant solutions. In the cattle and livestock industry, there are also some very interesting persistent problems that we can tackle with Astrocast. Typically, how do you eradicate some of the bovine disease? Well, some of the government are looking at our solution right now to try to identify which cattle is sick and needs to be removed from the herd as soon as possible. And using satellite, miniaturized low-power satellite technology is a very interesting way to do it. Predictive maintenance of a different type of infrastructure like power lines, water distribution system, gas distribution system, monitoring of emissions from these large vessels, different type of emissions. We have a project ongoing with this. And then you have everything about SOS and emergency signals. We can create panic button type of applications for life jackets, for cars, and there are several applications in that field that require a low latency that we will achieve when the full constellation is deployed. So this gives you just some ideas of what are the sectors where we can have a strong impact, and we will also focus a lot on the sustainable project where we can bring some smart solutions. So we have raised a significant interest from the market. We have found the right partners. We have a great teams with the right skills. We have also found some very supportive investors with the right mindset. So now we are really convinced that we can fully deploy this network and that we can build a success story. It took us 5 years to get there, so a lot of patience, a lot of endurance, a lot of persistence. But now we're ready, and we're exciting to see the next launches coming and growing this network of nanosatellites. So now let's watch a short video that we released recently that will give you a better idea of the sectors that we can address.
You are an innovator. You're in the business of making new discoveries, going further, being the first, and doing more. Your business is global, and you have assets in some of the most remote places around the world. You need to securely communicate with those assets, whether they are in the furthest ocean, highest mountain, or deepest desert. You need a way to reliably monitor and maintain your assets, whether they are a flock of sheep, a series of weather stations, a life-saving vaccine, or a fleet of vehicles. You need low latency, low power consumption, two-way communications, machine to machine, device to device. You need Astrocast, designed by the makers of the Swiss Cube, the world's longest-lasting nanosatellite. The Astrocast nanosatellite network is designed specifically for your business. Astrocast's low Earth orbit network lets your assets call home from anywhere in the world at an affordable price. Today, more than 90% of the world remains without connectivity. Astrocast helps you bring your innovations to the entire world. With Astrocast, your business is truly global.
Thank you. Hope you enjoyed this short video. If you want to watch it again, it's on our website. For the second part of this presentation, I'd like to talk a little bit more about the technology, as I guess a lot of engineers and future engineers and experts, technology experts, are interested to know a bit more. So, what you see here on this slide is the chip that we have been developing together with the CEA in France, and Airbus was also involved in that development. It's a development that took many years until it reached maturity, and now we're getting ready to produce it in large volume for our customers. So this is the heart of our product, which is a communication module that I'm going to show you now. Yeah, here on the left side, you see the communication modules. It looks a bit like a cellular-based communication modules. The difference is that it's a satellite link. It is very miniaturized, and it has to be very inexpensive. So just to give you a rough idea of the pricing, for the chip itself, we intend to be well below $10. And for the module itself, we will be well below $50. This is the threshold you have to pass if you want to really go into mass market and large application with millions of devices. Our goal is really to deploy millions of these devices, and this hardware, this product, can be integrated in any type of product together with an antenna, and then this becomes an enabler to start data subscription plans that will cost between $1 and $10 per month, depending on the data usage and the applications. So this is really how the business model works. It's a very traditional model where we make our business on the data plans, on the data subscription plans, and to enable that, we need to sell a very low cost and very low power, very practical communication modules that can be easily integrated in different types of products. Let's talk a little bit about the satellites. We're going to launch 80 of them. Most of them will be on polar orbits. Some of them will be on equatorial orbits. The altitude will be about 600 kilometers. We are in the 3-unit class, so about 5 kilograms. The price of manufacturing these satellites is below $200,000, which is very low, very efficient, especially given the fact that we are building them in Switzerland. We're very proud of having such a reliable platform at this low cost. The lifetime of these satellites will be up to 5 years, we have a long heritage of nanosatellite development now in our team, and we brought also some people in the team that help us make sure the space segment will survive as long as needed in space. We do have propulsion on board this satellite, which allow us to make different type of maneuvers. We can avoid debris if needed. This is extremely unlikely, but as you know, it might become more and more of a problem. So we are ready. We have everything on board to make sure we can react to this. And we also use the propulsion to initiate the deorbiting, so that we've really controlled the lifetime of the satellite. And when we decide to retire the satellite, we simply deorbit all of them in the much denser layers of the atmosphere, and they just burn and disappear. So that's the satellite. This is how the deployment will look like. So you can see that we have a triple solar panel deployment. That is one of the core technology on the mechanical part. There's been a lot of effort into this deployment, and this allows us to produce enough power to not only control the satellite and do all the operations, but to really communicate with millions of devices on the ground. And here is a picture of the real next 5 flight models that we will launch later this year. They're ready in our clean room, ready to be integrated in the rocket. We're going to launch them on SpaceX at the end of the year, and we're looking forward to this launch. I'd like to conclude this this presentation with one of the most emotional moments of this adventure that we went through as a team, which was our second launch on a Falcon 9 rocket from SpaceX. This was a bit more than a year ago. It was an absolutely beautiful launch on a very impressive mission. There was a lot of satellites on that rocket, more than 60, if I remember correctly. And it was a rideshare from spaceflight called the SmallSat Express. And just to give you an idea of how it looked like on the rocket, so you had this free flyer. So the third stage was separated in 2 parts. You had this free flyer here to the left, and we were in one of these blue deployment system here, and we were one of the last to be deployed. It was actually a very complex deployment sequence, including more than 60 satellites, as I said, on satellites of different shapes and size, as you can see. And not long after the launch, the deployment, so we were among the first to establish contact with our satellite, and this was just a fantastic moment to share with the team. And we haven't lost contact since that moment. So this satellite has been extremely reliable. These precursor missions allowed us to demonstrate the system, to fully de-risk the technology, and to involve also customers and partners. Airbus was also highly involved in testing a campaign that they did from Toulouse. And now we're very confident on our ability to provide a global IoT system that is reliable and secure. And as a last slide, I'd like to simply say that none of this, I'm convinced, would have been possible if I did not have the opportunity as a student and then as a young engineer, the opportunity to be involved in a fantastic educational project, in that case, the Swiss Cube project. This was really the trigger for me, but not only for me. There are many members of this CubeSat project that are now part of the Astrocast team. We have all learned many important lessons as students and as young engineers on this project. And I truly hope that some of you in your specific field, in your specific project, you will enjoy the same lessons learned, and you will be able to continue the development you have initiated, continue exploring your innovative ideas, and potentially develop a sustainable business model. And I really hope for you that you will be able to enjoy the journey of creating a company, trying to remain focused on important problems that need to be solved and that matter to you. And really, I was amazed by what you were also able to achieve given the COVID and everything. So it was beautiful to see this energy, even though everything was done remotely. So with this, I will conclude my talk, and thank you very much for your time and attention, and I'm open to questions.
Thank you, Fabien. Most inspiring talk and interesting talk. We have a lot of questions from the audience, so please stay with us for this Q&A session now. And Fabien, if you allow me, I will split the questions in 3 categories. So first, I'm going to ask you a bit about, this student project that you conducted 10 years ago, the startup life, what you recommend to the IGLUNA teams and our audience here on this live stream. Maybe go a bit deeper in technology, then a few questions about exactly what you are doing, and maybe some more general open questions about, space degrees, Mars, and the moon horizons, and the future missions that you will conduct with Astrocasts. So yeah, first question, thank you for the message at the end to the IGLUNA teams. Totally agree with you. They've done great technology development. They usually have a great team around them. And maybe you can tell them also what you would recommend doing after their masters. So most of them are master students. They have a few teams members around them. What would you recommend as a next step after IGLUNA really? So now they have the technology ready, and how to launch it, go to the next step.
Well, it all depends on the project, but I would say the next step would be really to assess the business opportunities. Sometimes we are fascinated by technologies and innovation, but we forget that to really give a chance to this technology or these solutions that we have found, we need a market, and we need to be able to sell that to someone, and this is how we can make an impact. So really, to go deeper in the business modeling and trying to challenge the idea, involving people of your field, experts that will challenge you not only on the technical side, but especially on the business feasibility, and test your ideas with potential customers or future users. I know the ideas you're working on are very long term, and it's on the moon. But we're getting there. At some point, there will be an economy, viable economy on the moon, probably, and you have to transport yourself in that moment and really try to challenge this idea from the business point of view, I would say.
So I understand from what you're saying that students should not only focus on technical issues, but also on the business model. Of course, you're the CEO of Astrocast, so you had to do this exercise, but not everyone in your team did that. How do you move from technical to business mindset as an engineer? It's not always easy in our field to challenge our business case properly.
Yeah, this is a very good question. Absolutely agree with you. It's hard. I was an engineer, and I had to completely change my mindset. I had no choice, so I really had to find a way. But I was convinced since day one that there was a path, and really this path evolved and changed several times, but it's really by starting discussing, going out of the lab and expose yourself to the real world and the people who might be willing to invest, the people who might be willing to support you. And this is when you start asking yourself the right questions. But this transition is not easy, I would say, and you need really to challenge yourself. This is something that you don't do in one day, you do it progressively. But I would say having the technical background is an extremely strong asset that you should leverage and that you can use to convince, to show also the confidence you have in your technology and your ability to solve these important problems.
Following that, we have a question from the audience. How did you find your first investor, and how did you talk to them with your, at the time, very technical mindset? How did it go?
Well, the first people who invested in the company were what we call business angels. So they were looking for something like that. They understood at least a little bit the industry. So there are people who have not only the money, but the desire to support a great team of young engineers. And they can bring that experience and that support that you don't have as a young team. So you need to look for these people. And in our case, they were, guys who had a strong interest in the space industry or in the telecom industry, and who clearly understood the potential. Even though we were not ready, we were far from having something that was fully functional. But again, we find a way to clearly explain the path and the roadmap and how we could get there. We didn't know exactly how much money we needed. We knew it was a lot. We didn't know how much exactly. We didn't know how much time it would take. But again, challenging your ideas with people from the industry help you make this progressive step. So in our case, we started with a few business angels who invested a little bit of money that just helped us move to the next step of this roadmap. And when you move to the next step and you show that you can hit these milestones, then you gain credibility. And with a bit more credibility, you can access different types of investors. And then you see the corporate investor, you see the industry getting very interested. In our case, it's Airbus. Airbus invested in the project early on, and this was extremely helpful also for the credibility of the team. So it's really a step-by-step approach, especially if you're in the hardware business. In the software, I would say you can go much quicker in your development, but if you go for a long-term, difficult business plan with a lot of hardware development, then you really need to think about this step-by-step approach and convince the right people at the right time.
Thank you for this explanation. I think it's really useful, especially for people in the hardware systems like you. It's a very long journey and cycle of investments, and you have to go step by step. Thanks for this advice. You said it before, talking about your competitors, that you guys have 10 years, at least 5 years behind you, and you're quite advanced technologically speaking compared to your competitors. But who are these competitors that we are talking about? That's a question for the audience.
Yes, so there are existing players, the established satellite players. They are our competitors in the sense that they have been there for a while, and we're going to disrupt some of their market share. And these guys are the well-known, Iridium, Orcom, Globalstar, Inmarsat. They provide M2M IoT solutions. But this is today. It works well. It's reliable, etc. But it's very expensive. And then you have all these new projects like Astrocast. We know there are about 15 of them. I would say 2 or 3 that looks serious. And I'm not going to mention names here, but there are many people like ourselves who just started to have some good knowledge about either IoT protocols or satellite telecommunication on small satellites, and they saw the opportunity. And really, IoT is the next big opportunity for nanosatellites. You know, most of you know the story of Planet, which was very inspiring also for us. They are focusing on imaging the planet, and they are doing it quite well, as far as I know. And we looked at that, and we thought, oh, this is already quite saturated. There's no room, there's no need for a second planet. And we took this opportunity for IoT at the right time, at the right moment. And we will see a lot of players trying to grab as much share of that market as possible. But what's important is not only to be the first, but to have a solution that has been well tested and that's reliable. Because once your customers deploy all these assets in the field, they cannot go and change something. It's a little bit like when you launch a satellite. You cannot ask our great astronaut to go and replace something like he did on Hubble, right? So it's something that that requires some time and effort, and we think that we have this maturity now to really securely deploy the network.
Thank you again for this answer. So from what I understand from your answer is that people should come work for you and not your competitors or their CubeSat constellations, even in the Earth observation segment. One question from our audience is, what should we do to work for you? I mean, do you guys hire, and what type of profiles are you looking for? And if somebody wants to join your new offices next to EPFL, how do we do that?
Yeah, so this is also one of the reasons I wanted to talk at your program is because we are looking for talents. We're looking for the great engineers who understands the new space, etc. So we have a lot of open positions. We are creating more and more. We're a fast growing team, and so you can find details on the web on our new website, and you can always send your applications if you'd like to talk with us. And we receive a lot of them. It's not easy to go through all of them, but we're looking for talents in very different fields, engineers, but also on the business side, obviously the regulatory side. And yeah, there's room for champions.
Great. I hope to see a lot of IGLUNA people joining Astrocast in the next months and years. That would be awesome to have a bigger family here in Switzerland. Small question about your business model. We saw in one of your slides that the model is actually not to sell your satellites or chips, but more like a monthly subscription for IoT data packages. Can you tell us a bit more about this type of models? Is it common in the field? What size of market are you expecting? Is it really profitable? And there will be other players in the maybe not the IoT, but more broadband data packages from CubeSats like Starlink or Kuipers. How do you see these projects?
Yeah, very good questions. Thank you. So this is correct. Our business model is based on data subscription plans. This will depend on the data usage and the sector, but it's very low cost. It's really IoT. We're talking about small amount of data per day per asset, about in the order of a kilobyte per day per device, and the market is quite huge. It's growing exponentially. There are different studies that are available on this topic. And so you have the market of the existing users of satellite system that are a bit frustrated by the high cost, and they will switch quite easily to a lower cost system. And then you have the market who could never afford satellite connectivity. And if you look at the livestock industry, if you look at the fishing or the maritime industry in general, is very important. So we believe that by 2020, 2025, there'll be at least 30 million devices connected through satellite. This is the addressable market for us, and we hope to get the lion's share of this market. And with regard to Starlink or Creeper, this is a question that comes quite often, in the sense that we hear a lot about this project, and it's also extremely inspiring for us. But they are on the other extreme of the spectrum, in the sense that they're really broadband provider. So the type of infrastructure that you need, the type of frequency that you use to offer broadband service is very different from what we do. Just to give you an idea, the size of our antenna is going to be something like that. I don't know if you can see it. If I put it here. So still the size of you may have seen on the social media. There are pictures of the next generation of ground terminal for Starlink. They're still quite big. We're talking about the size of a pizza box, right? So it's a very different type of infrastructure, much more expensive. But then you can transmit a lot of data. You can stream Netflix. You can do a lot of things that we cannot do. So it's a very different market, and we don't see this at all competing with us in the future. We think it will even have a positive impact on our business.
So since we started talking about technical details and that you showed us our antenna, we're going to move to the next category of questions. I'm sorry, I will not be able to answer all the questions from the audience. Today, we only have 15 minutes in front of us, so let's make the best of use of Fabien here and ask him the more relevant questions. Maybe talking about antennas and frequencies, which frequencies are you using? What size of data packages or bandwidth are you actually using there? How does it look like for someone not from the technical, with a technical background? You know, you have two antennas, one on the ground, one on a CubeSat orbiting. How does it work?
So thank you. A lot of questions. The frequency we use is called the L band. It's the same. It's the spectrum between 1 and 2 gigahertz. It's the same band used for the GPS or the GNSS services. It's by far the most efficient spectrum for IoT through satellites, for different reasons. One of them being the miniaturization of the antenna, which is important for many products. By the way, this is also one of the reasons why the GNSS is based on L-band. It offers a lot of advantage. It's not sensitive to rain, fade, and the power consumption you get with our devices is pretty amazing. We are about 7 times lower in terms of peak power consumption than the existing solution on the market. How does it look like? So you have really on the ground, let's say you want to connect a car or a truck. You have a small module that is about 4 by 4 centimeters, maybe smaller than that. It's the one I showed in the presentation. You have to integrate it in the telematic box of the vehicle. So this is done by our customers who are mostly systems integrators. And then you integrate the antenna. It could be a patch antenna like this one, or it could be a different type of L-band antenna. And this will establish a communication directly with the satellites in orbit. And you will have, depending on the number of satellites that are in space, you will have the opportunity to send your message X times per day. At the beginning, we start with a high latency, but when the system is fully deployed, we go down to a few minutes. And we guarantee the 15 minutes delay, but in many cases, it's going to be better than that. So once you reach this low latency, it opens up many markets, like the panic buttons that I mentioned, or solutions like this one. This is a small satellite personal tracker with a SOS button. This is a market we can potentially also address. And you can send text messages. You don't have coverage with your phone. You can send text messages through a system like this. And the many applications that could be very interesting, even for people here in areas that are well connected. If you go hiking in the Alps and you break your leg and you don't have cell coverage, you can still send an emergency signal.
Very good. A bit more into the technical details. Why LEO? Why low Earth orbit for your CubeSats? Why do you need to be so close to the ground?
The fact that we're close to the ground does not change a lot for us, because when we talk about low latency in the IoT market, we're not talking about milliseconds or below. We're talking about minutes, and so it doesn't change much whether it's GEO or LEO. It's simply the fact that it's a lot easier to launch a network in LEO. There are a lot of launches available. Gives you also the ability to fully cover the planet, including the poles. We actually have a very good coverage of the poles because all the satellites are going up and down to both the poles, and then the Earth is rotating, so you can really scan the entire surface of the planet. So it gives you a very good coverage. And then the environment in terms of radiation is very, if you are below a certain altitude, in our case, we are around 600 kilometers, the radiation environment here is actually very easy to handle. We know that really well, we've experienced in that altitude. So we think that's the best way to do it, for also a lot of other reasons. But we are also thinking about the potential of building, in the long term, building a hybrid system that could also rely on GEO satellites, as our system is potentially able to close the link budget with the GEO satellites. And this could be, especially for specific areas, specific opportunities, this could be extremely interesting in the long term.
Maybe a small question about all the journey from your CubeSats in your lab in Switzerland until the launch. We saw that you use American rockets. Why not European rockets? Do you have all the facilities to test the dispatchers and your CubeSats in-house, or do you do that also over there? Vibration testing and all quality testing in the journey. How does it go for you? Why choose this way to launch?
Let's start on the testing. So yes, we do all the testing internally. So we have all the facilities except the vibration testing that we do. We found a very good partner to do that in France, and it's going well. But everything else is done internally. Then, well, except the radiation testing. When we do specific radiation testing on some components, we do not have. Maybe in the future, maybe with more investment, but not at this stage. Speaking of the launch, we do launch with European. We have 6 launches that are booked right now. So this is going to put in orbit our first 50 satellites. We are working with aggregators like Spaceflight and D-Orbit. We're not working directly with the launch providers, which gives us a lot of flexibility. This is what is happening right now. For example, with the COVID, we are losing some visibility on the Indian launches, and so working with integrators gives you this ability to make changes on the launch, on the rockets, basically. And we do launch with SpaceX now because they are extremely reliable, even in the middle of the COVID. This is very, very impressive, actually, to see them continue to launch so many satellites in these conditions. But we do have launches with the Indians, obviously. Most of our launches are with the Indians, PSLV, and the new launch vehicles as well. And Vega from Ariane Espace. Especially for equatorial orbit, we will rely on Vega.
Glad to hear that you're also using European launchers. Maybe one last question. We have 5 minutes left, less than 5 minutes in front of us. I'm going to ask a general questions about, space debris, sky pollutions. What do you tell to astronomers that, are you polluting the sky? You talked about having a propulsion system on board to deorbit them. Why not using another Swiss startup, ClearSpace, to do that?
Very good question. So let's start with I have a good friend of mine who is an amateur astronomer. He's really good. He has this nice telescope in his garden, and it is actually a problem from the if you listen to the astronomers, the community, they are not very happy about that, and there are ways to remove the noise from these pictures, but it is an issue. But I think SpaceX has been very proactive in trying to solve this with the new visor system and the painting, etc., the coatings. I don't know the details of that, and I do hope that this will not disrupt or cause more problems to the community. On our case, the satellites are extremely small, and the solar panels are on the opposite side. They're not looking down to the ground. The only part that is looking to the ground are the antenna sides, as you can see the satellite on the website. And we have not make any measurements, but the reflection must be extremely low and should probably not be seen at all. The lifetime of our satellites is short, so we replace them. It's part of the business plan. We replace them every 3 to 5 years to bring in orbit the best technology, because the technologies are evolving so quickly on the ground that after 3 to 5 years, your satellite is obsolete, and you want to launch a much more powerful satellite. So we think we have a very good system in place that is sustainable. Even if we lose control of the satellite, we're low enough to deorbit in much less than the 25 years guidelines from ESA. And we do not intend to lose control. We have very good and safe system in place with a lot of redundancy. For the propulsions, we have done some testing. We are working on the next generation of our satellites already with new systems, and this is also a field that is evolving very rapidly. So we're looking at all the new technologies available. And with that, we think we really have a system that is sustainable. We are very sensitive to the debris question because of SwissQ. For those who know the story, we were on the same path as a lot of debris from the collision between Iridium and the Russian satellite, which also triggered this awareness of this issue. Even though it's still extremely unlikely and the density is extremely low, it is a growing problem and we have to address it. And I think it's the responsibility of all the small sat, nanosat and larger satellite operators to take this in account. And we are very supportive of the initiative of ClearSpace, for example, who is doing a great job with their team here in Switzerland as well, and many other teams in the world who are tackling this real long-term issue.
Thank you, Fabien, for taking this issue so seriously. I'm very pleased to hear that. And I'm going to make the transition to the schedule of tomorrow and maybe ask a very short last questions. We have 2 minutes left. So tomorrow we have 2 more student project shows, so P11 and P12. P11 is planning to launch a cislunar communication system around the Moon and Mars. And is it a market that you also want to move forward to, or is it something that you would rather do partnership with another company then?
Well, this is a great question. To be honest, we are focused on much closer objective, but we had discussion about that already with some of our partners actually. And one day there will be a need for that, I believe. Launching a constellation around the Moon and the environment around the Moon or Mars is very different from what we have here around the Earth. And therefore it's a completely different mission, obviously. But I believe there is a need for IoT, and we hope that we will be involved in this project.
Thank you, Fabien. Thanks for joining us today, and I hope to see you all tomorrow for other interesting talks, space expert talks, and IGLUNA Teams project shows. Thanks a lot.
Thank you.